So the first question, this has been asked in Amazon, and the core principle behind this question is hashing, but we won't discuss that right now. So what you need to know, these are the easy questions. So the first question is like that. Um, so you need to find a pair with the given sum in an array. Okay. So we have a unsorted integer array, and we need to find a pair of elements whose sum is equal to let's say k. Okay, so here like in the example it's given 8 7 2 5 3 1. Okay, these are the elements of the array, and taking any two elements the sum should be equal to 10. Okay, so what we can do, like what should be the solution? So the first initial thought that we have in our mind is like going with the brute force method. So what we can do here, uh, take the first element and then iterate it, like take I from 0 to n, like from here to here. Like n is the like the whole length of the array. Okay, number of elements present in the array. So now what you need to do, you need to take j, which is equals to I plus 1 to n. Okay, so we will be iterating j from here to the n. So what will happen if a of I plus a of j is equals to sum? That means we have considered this element, and then we will be iterating it through the whole array. And if we get any element um, whose sum is equals to a of I plus a of j is equals to the given sum, then we would return these indexes. Okay. Yeah, we need the index for those elements that whose sum is equals to 10, or the given sum. Okay. So similarly, for the next element, it will check and it will iterate from here to here, and similarly it goes on. So the time complexity is O of n square. Why? Because for every ith element, we are going to repeat the step n times. Okay, so it is going to be for n elements, n into n square. So O of n square, brute force method. Okay, now what would be the second approach that we could have here? Okay, let's see. Okay, so the second approach is sorting the whole algorithm. If we sort the algorithm, then we would know uh, where uh, where would those elements be, right? Uh, so after sorting, the small elements would be on the left side, and um, the higher elements would be on the right side. Okay, so what we can do, we could sort the algorithm that would take n log n time. Okay, and then we could use a while loop. Okay, so we would be having two pointers here, or indexes, to point out. Okay, one is less, one is more, or you could call it low or high, anything. Okay, so what will happen here, you will be having let's say if we add the first element and the last element, and if that sum is equal to uh, the given sum, then we would print out those pointer elements, indexes. Okay, if not, if it could be either of the three conditions, right? So if it could be equal to, or it could be greater than, okay, or less than. So if like here, if we calculate the sum, 8 plus 1, that's 9, and 9 is less than 10. Okay, so what we need to do is we will increment this less pointer to the right side, or increment it 1. Okay, so what will happen, the number is increasing in on the right side. So as the number increases, we will get closer to that number, the given sum. Okay, And if the sum is greater than like if we have incremented it here, so the sum would be 2 plus 8, that is 10. So that's correct, we could print those two indexes. Then if we increment it more, then what we will get here is the sum is more than 10, that's 11 right now. So what we need to do is we can decrement this pointer, the more pointer, to the left side. Okay, move it to the left, or you can say decrement it. Okay, so once it's decremented, then you could see again the sum is equals to 10. So we can print out this. So what will happen here? We will have the whole array in a sorted order, and we know the position of elements. So we will take two pointers and we will um, propagate through it, uh, moving both the pointers, and it will take on um, time complexity plus o n log n. So that would be equal to o n log n. Okay. So the third method here, this was not using any extra spaces, but the time complexity was more. So the time complexity was n log n, but the spaces used was constant because we were only going through the array. Okay, we were not creating any other array or something like that. So the third approach is using hash map. So what happens in a hash map is we will take all the elements and we will check its occurrence. Okay, so let's say yeah. So here in hash map, what we will do, we will take the elements. So like the given element is 8, 7, 2, 5, 3, 1. Okay, so we will put the indexes of these elements. Okay, and the index is 0, 1, 2, 3, 4. So we actually need to print the pair, the element that are required. Okay, so the second method was using that. It won't give you the exact indexes, so keep that in mind. uh, so we would be having these elements, and we have put in a hash map. Okay, so hash map will works on the principle of key value. Okay, so the key here is integer, and the value is also an integer. So what I'm keeping key is the e of element, and integer, the value, it's the index. Okay, so what we can do, we will iterate through the array, and we will check if um, the sum, the given sum is 10 minus e of I, element is present in the hash map or not. Okay, so if that element is present, we will print these two elements and we will have that pair. Else, what we can do, if that element is not present in hash map, we will continue, but going through the array, iterating through the array, we will be having elements that are not present, right? So let's say for the first time, while the hash map is empty, we went through 8, and what we will do, we will keep the value as the key, sorry, the e of I as a key, and I as the value inside the hash map. So here is a pseudocode here for that. So we'll iterate the array from uh, 0 to n, and then we will check if it contains the key whose value is this. Okay, so that is the sum minus e of I that we are having. So if that's there, then we will print both the elements. Else, what we will do, we will put these two inside the hash map. Okay, the element in the hash map. Okay, so this has it takes on time, but hash map needs extra space, so on extra space is required, and like getting values from hash map, it takes a constant time, so o of n, so the total time complexity is o of n. Okay.